Alright guys, welcome to the video. We are gonna do something really great in this video. We are gonna make a neural network predict whether a person is gonna suffer from diabetes or not in the future. So let's get started. But before starting this video, here is the thing. This video is gonna be long. So here is the thing. I can make this video short and I can just read the code that I already did in my article, but that won't help you. You won't learn something. So I am gonna do everything step by step. I'm gonna code with you. So this video will be a little long, but would be very informative. I'll definitely assure you that. So let's without wasting much of time, let's get started. So let me pull up my Jupyter notebook and let me show you what we are about to create. And this is really amazing. So we have the data set. We are going to clean the data set. We are going to read the data set. Then we're going to rename the columns. Then we will normalize the columns. Then let us apply a custom lambda function. After doing all that, we'll do train test split. Then we'll create the feature columns. After creating feature columns, we are going to create a neural network which will predict the diabetes. The accuracy is 77%. So let's get started, guys. So this will be a little long, but stay with me. You will learn a lot. I definitely assure you that. All right, so we'll go step by step, not in a hurry. We have a lot of time, so let's get started. So first of all, we need to import the library of TensorFlow. So import, so I'm gonna say import library, right? Now let me make some lines here in order to save some time. So the first thing that is we gotta import the libraries. I am gonna do a little copy paste from my notebook, so in order to save time, otherwise this video would be very long. All right, so let's get started. So a little bit I'm going to do a copy paste. So first of all, we need to import the library. So let me just zoom in a little bit so you can see. So we need TensorFlow, NumPy, sklearn. We need a train size split. We need pandas and matplotlib to plot. So let's get started. So first step is done. Then we need to what we need to do is we need to read the data set. So the way to do that. So read the data set. You are going to use pandas to do that. So the way to do that in pandas is df equals to, as you guys know, data frame equals to, why there is a full stop. So I'm going to say pd underscore read underscore csv because I'm going to read a csv file. By the way, the entire text version is also there on my GitHub. If you don't want to watch this video, go to the GitHub, check the entire text-based version. So first of all, I got to read the data set. So the way I'm going to do that in pandas. So I'm gonna say pd underscore read csv, and then I'm gonna say the name of the file. So and if I run this, so here you can see I get all the names of the name of the column. Now I need to rename the column, right? So I can simply say, so by the way, let me show you from where did I got this data set. So if I go to Kaggle, this is a website to get all the data sets for your machine learning neural networks. So if you go to the data set, and if you say the diabetes, I think I made so you can say Indian diabetes. So here you can see this is the data set that I used. So make sure to download it and use it. So first I have the data set here. So here you can see I have the entire data set. Now I need to rename the column. So this data set right here on the website of Kaggle. So if I open this Pima Indian diabetes.database, so it gives you details about the list of the column. The first is the pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree, age, outcome, and so on. So we need to rename the column. So I'm going to copy all of these column names and I'm going to rename that. So the way to do that is this call name is equal to, we're going to prepare a list of all the column names. Now we need to rename our columns. So the way to do that in pandas would be simple this. So I'm going to say read CSV. Again, I'm going to read the file. I'm going to say header equals to 0 and names equals to column names. So these are all the names. So if I print this, so here you see now the data frame, the name of the column has been renamed. All right, so that's beautiful. We did it. Now we need to do something really very important. We need to normalize it, normalize the data. That means we can't feed all 85, 183 to a neural network. It has to be between 0 and 1. So we need to normalize it. So let us apply a custom lambda function to normalize it. So so let me show you. There are two ways so to do this. So I'm going to show you the easy way. So let me zoom a little bit so you can see. So I'm going to say df1 underscore norm. So this will be my data frame that I'm going to perform the normalization. Then I'm going to say df and I'm going to say columns to norm. So I need to pass the columns that I need to normalize. So before that, let me create a list. So basically this would be a list of columns. That is my feature map. So in this, if you observe carefully, let me just zoom out a little bit. Yep, so I don't need the class. This is what my neural network will predict, right? So I need to drop this. So I need to create a new data frame known as df underscore norm is equal to df, and I'm going to pass call underscore norm. So this will normalize all the columns. So if I print df underscore norm dot head, right, and I'm going to print that. So here you see now the class function, the last column that is a class has been dropped. So here you can see that. Let me create some more space. So once you have done that, that means you have the data frame. Now what you guys need to do, we need to apply a normalization function. So I'm gonna apply a custom lambda function to do this job, and the lambda function would be, so let me say df1 oops df1 underscore norm underscore v. That means this will be a normalized column value. So I'm gonna say df, then I'm gonna say columns to norm, right? So I selected the all the columns from the data frame that I need to normalize. Then I'm gonna say apply. All right, so I'm gonna apply a custom lambda function here. So I'm gonna say lambda x colon. So x means it will be the value that I want to pass to this function. Then if you've not watched my videos on lambda function or magic function, make sure to watch that. I've explaining there what is lambda function. So in order to normalize, I would say x minus x dot min. So subtract the value with the minimum, and then I'm gonna divide it by I need to divide it by the min and the maximum. So this is how it looks like. Just in order to save time, just doing a little copy paste, so otherwise this video would be too large. So now if I run this df underscore norm dot head, so if I say head, if I print it here, you can see I have normalized the column. That's beautiful, guys. So congratulations. Now we need to do we need to create our neural network or a train test split. So let's do that. So before that, we need to now we need to create a feature map column. So here you can see we have pregnancy, glucose, blood pressure. So these are what our feature maps. So we need to create all the feature maps. So we're gonna say feet underscore p. Let me just copy that. I'm very lazy. All right, so I'm gonna say so tf dot, and you can say feature map. So I'm gonna hit the tab button, feature. I'm gonna say feature column, and this is a numeric column. So I'm gonna say numeric column, right? And I am gonna complete this, and I need to pass the name of the column. So the name of the column, of the first column, that is of the feature map column, would be pregnancy. So inside the double quotes, I'm gonna do that. Oops, sorry for that. Crazy. All right, so copy that, paste it, run it, done. Now similarly we need to do it for all the columns. So let me copy it from my Jupyter notebook. So here you can see I'm doing that for each and every column. So once you're done that, now we need to create a feature column. So this will be a list of all the columns. So let me just write feet underscore call equals to, oops, I'm gonna say feet underscore calls equal to. So this will be a list, as I said. So here would be a feature pregnancy. So make sure to enter that. Then the next value would be feature glucose. And similarly, so make sure to copy all of that. So once you've done that, so this is how it looks like. So I created a list of entire feature columns. So once you're done with that, now we need to perform a train split. We need to have a training data and a test data. So let's do that. So we have to import the scikit-learning to in order to do that. So I'm gonna say now say train test split. All right, so I'm gonna say x underscore train comma, then we have x underscore test comma x, oops, sorry, y underscore train comma y underscore test is equal to train test split, which is we already imported the library from scikit-learn, train test split. Then we need to pass in the x data and the y data. So before, we do not have the x data and the y data, so let's create our x data and y data. So Remember, what is our y data, which is nothing but our column that is gonna our neural network we want to predict it. So from this data frame, this one is our y data. So let me try to create that real quick. So y data gonna be df class. So we this name, the name of the column was class, right? So here you can see class. So just doing that. So we have the y data, and similarly, what is our x data? The entire column to norm. We have to get the normalized column. So let me copy this. Oops, my bad. So this is our x data. This is nothing but our df to norm, which is we just perform the normalization. These are all are our the x data, because we need to. So if I run this real quick, here you can see this is my x data. Now similarly, I need to do for my y data as well. All right, so I have my y data. Once I have the x data, I have the y data. I need to perform the train test split. So I'm just gonna supply an argument known as x data, y data, test size equal to 0.3. That means 30% of data would be reserved for testing, and 70% for the data is reserved for the validation or for the training. Now we need to create our model. So first of all, we need to create an input function in order to create a model. So our input function would be input func. Then we need to create an estimator. So you just hit the tab button on the keyboard, it will automatically complete that. Then we're gonna say input, since it's an input. And what is the input function? It can take two arguments. It can take a numpy value and a pandas. So we are supplying the pandas module. And so obviously our x would be what? X train. Similarly, our y would be y train. So we supplied the x train, y train. Now we need to say a batch size, which would be 10 for this. Then we can say number of epochs, let's say 100. And of course shuffle equals to true. We want to shuffle the data. So now similarly, we need to create a test function. So test underscore func. So I'm just gonna copy this and paste it here, because it's gonna be the same thing. Instead of input, let's say test. Instead of x train, it's gonna be x test. Instead of y, it's gonna be y test. So the number of epoch has to be 1. Since we are doing testing, we don't need to let me just increase the brightness a little bit. So the number of epoch has to be 1. The batch size would be same as above, and shuffle equals to false. All right, so we created our test function. Beautiful. Oops. Right. All right, so we did that. Now we need to create a model. So our model would be model equals to tf dot estimator. So we say tf dot estimator, and then we say dot linear classifier, because we would be using the linear classifier. And what we want to do to this model, we want to supply our feature map column. So our feature map would be feature columns. So we'll say feature. So feature columns, that is nothing but all the data set that we want. So that will be our feature column that we just created here. If you remember, let me show you that. So this is our feature column. We created a list of entire feature columns. So pass in that. All right. So we said feed calls or whatever it is. Let me just paste this here. All right. So it will take the feature column, and n class is equal to 2. That means since this is a binary classification, we want 1 and 0. So I'm saying n classes is equal to 2. So once you're done that, we need to do a training on the model. It's as simple as saying model.train and supply the input function. That's input function. We create an input function, supply that, step equals to 5000. Now let me close this and open up a very detailed article that I've already created for you guys. So if I bring this here and I'm gonna again walk you through the entire stuff that I did, so you can read it again if you want. So first of all, we imported the library, then we read the data set, then we rename the columns. Once we're done with that, we need to normalize the column. Once we're done with that, then we need to get the X data and the Y data, right? So here you see we got the X data, the Y data. Then we need to create a feature column. This is nothing but our all the columns that we need to pass to our neural network. So I create the feature columns. Then we need to create a list of all that columns. So I just create the list of all that feature columns. Once you're done with that as well, then you need to do is perform a train test split. So we have to 70% of the data for the training, 30% for the testing. Once you're done with that, we create our estimator model. Estimator model is nothing but the function. So we supply the X train, the Y train, the batch size is 40, number of epochs 1000, shuffle equals to true. Then we need to create our model, which is a linear classification model. So I say model equals to tf.estimator.linear classifier. We supply the feature column that we want to pass, which will be the list of entire feature columns. Here you see. And we say n class equals to 2. Since it's a binary classification, if you run this, it will give you some messages saying that your model has been created. Once it is done, we need to run the model. So we can just say model.train on the input functions. We already created an input function right here. So here you see. So we perform a run on the model. So if I say control enter, of course it won't run because I need to run the entire code one by one. So I'm just gonna run it in a while. Let me just explain you. Then we create an eval function that's nothing but the test function. Then we just say model.evaluate eval function, and we pass in that input function, and it will give you an accuracy for about 74%. Oh, that was a lot. All right, so let's run this model and see how it works. So I'm running it right now. So first of all, it's gonna read the data set. It's gonna create the model. Now it's gonna let's wait. So right now it's doing it created the model. Now it's performing the training. So here you can see now it's training. We are getting the loss. So here you see the loss is decreasing. 27, 21, slowly it's decreasing. All right, so here you can see the loss is decreasing slowly. So let's wait for that to run. Oops, sorry for that. So still it's running. Here you can see I'm running for about how many epochs? 5000 epochs or 5000 steps. So still it's running. Now once that is complete, now I'm gonna do my testing on that function. So here you can see it's gonna do a test. So it's testing right now on the test data. I got an accuracy of 74% on the data. Now this is the DNN, that is a dense neural network model. So here we just did the classification model. We use the classifier. Now in the next video, I'm gonna teach you how to do the same task using a dense neural network. Which will give you a much higher accuracy for about 77%. So in the next video, I'm gonna be covering the DNN model for the diabetes dataset. So that's it for this video. Thank you for watching. Have questions, post them in the comment section, and I shall try my best to get back to you as soon as possible. I know this is a lot to take right now, but already the text-based version is already there on my GitHub. So if you go to GitHub and type in my name, which the links are already there in the description section below. So make sure to go to the link, and if you go to your repository, or you can just I'm going to provide you the link. If you go to the repositories, so you can say machine learning model for diabetes. So if I say where is that patient? Yep, diabetes. So if you go here, and the entire text-based version is already there, so make sure to read it, copy it, play with it. So here you can see step by step everything is given. So make sure to read this, and that's it for this video. I'll end my video right here. See you guys in the next video.